Hi everyone. Today we are going to see how to integrate some arithmetic expressions of this form using basic integral formulas. Myself, Prabhavathy, Assistant Professor of Mathematics, A.D.M. College for Women, Autonomous Nagapattinam, which is affiliated to Bharathasan University. Shall we start? So we are aware of the basic integration formulas. So to integrate these 4 problems, I am going to use the first integration formula, which is integration x power n dx equal to x power n plus 1 divided by n plus 1 provided n plus 1 not equal to 0. Because if n plus 1 becomes 0, so it is in the denominator, it will give the expression infinity, which is not allowed in our mathematics. So now let us consider the expression integral x power n dx, which is equal to x power n plus 1 divided by n plus 1 if n plus 1 not equal to 0. That is, n is not equal to minus 1. So this is general formula. Now first we are going to find the integral of x power minus 4 dx. So integral x power minus 4 dx. Students, you have to compare these two integrals and you can observe that the expression x is same. The power in the place of n, now we are given that minus 4, which is not equal to minus 1. So we can apply this formula. So which is equal to x power. So if you replace n by minus 4, what will you get? It will be x power minus 4 plus 1 divided by minus 4 plus 1. So which gives minus 4 plus 1 is nothing but x power minus 3 divided by minus 3. So this type of integrals, that is without lower and upper limits, are generally called as indefinite integrals. So for the indefinite integrals, the answer will be some approximate value. So every time when you are given to evaluate indefinite integrals, when you integrate it, after that when you write the final answer, you have to write plus c. That c denotes some arbitrary constant. It may be any value. So here c is an arbitrary. Constant. Constant means you can give any value. Okay. So this is a first basic problem. So you can use this similar method to solve some expressions involving 2 or more arithmetic expressions. For example, the third problem like that. So before that, let us solve this x power 3 by 2 dx. So first one we are giving negative powers, now we are considering positive powers. So both are can be integrated in the same way. So integral x power 3 by 2 dx. So here in the place of n we are having 3 by 2. So which is equal to same formula. So x power 3 by 2 plus 1 divided by 3 by 2 plus 1. So here also we observe that this 3 by 2 is not equal to minus 1. So we are allowed to use this formula. So plus some integrating constant c. So this will be x power 3 by 2 plus 1 will be 5 by 2. So x power 5 by 2 divided by 3 by 2 plus 1, the same value 5 by 2 plus c. So this 5 by 2 can be written as 2 by 5 x power 5 by 2 plus c. So, if it is given positive or negative powers of that x, there is no issue, you can use this formula. Only the condition is provided n should be not equal to minus 1. In other way, n plus 1 not equal to 0. Okay. So, now shall we go to the simple but combination of 2 or 3 arithmetic expressions in terms of x. So, third problem, having numerator ax square plus bx plus c divided by x cube. So, you know that you can apply formula for this expression, that is x power n dx. So, we have to convert this expression in terms of simple types of integrals. How will it be happen? So, just you have to do this expression separately, you can write, that is a x square by x cube plus bx by x cube c by x cube. So, I think you are aware of writing an expression in this form. So, now this can be written as, so you are here having the term x square divided by x cube. So, we all very familiar with a formula in mathematics, that is a power m into a power n equal to a power m plus n. Similarly, a power m divided by a power n is equal to a power m minus n. Okay. So, now our expression is this type. So, here a x square divided by x cube. So, this can be written as x power 2 minus 3. Okay. So, this will be b into x power, here power is 1. So, 1 minus 3 plus c, here x power 3. Here no terms are available. It can be considered as anything power 0. So, here I am considered as x power 0. So, this will be x power 0 minus 3 into dx. Okay. So, integration is linear. That means that you can integrate these expressions separately. So, this integration can be written as a x power 2 minus 3 is minus 1 dx plus this is nothing but integration b x power 1 minus 3 is minus 2 dx plus third term will be integration c x power minus 3 dx. 0 minus 3 is minus 3. Okay. So, now the first integration gives, so here you can take the constant, here a is constant. So, constant does not change with the integration, you can take it outside. So, the balance term will be x power minus 1 dx. So, plus, so b you can, it is constant, you can take it outside. So, integral x power minus 2 dx. So, plus the third expression is c times integral x power minus 3 dx. So, again you are going to apply this formula which is already in the right corner. So, I am erasing here. So, which is equal to, so as I said, here the power is minus 1. So, we should apply that formula only the power is not equal to minus 1. So, here you cannot apply the integral x power n dx formula. So, there is separate formula for this. What is it? It is nothing but integral x power minus 1 dx is, which is equal to integral dx. X power minus 1 is nothing but 1 by x. This formula is nothing but log x. So, first you write that constant as it is. Integral x power minus 1 dx is nothing but what? It is log x plus b is constant. So x power minus 2, it is not equal to minus 1. You can allowed to apply that formula. So it is x power minus 2 plus 1 divided by minus 2 plus 1. So plus third expression is x power minus 3 plus 1 divided by minus 3 plus 1. Okay, so that's all, we solve. So here you are given 3 constants A, B, C. So you cannot write again plus C because C is an arbitrary constant. You can use any notation. So already I used the notation C. So that's why here I am going to use plus some D. Okay. So the final answer will be, this will be equal to A log x. So minus 2 plus 1 is minus 1. So minus B, here will be x power minus 1. Minus 3 plus 1 is minus 2. So it will be minus C by 2 x power minus 2 plus B. So if you want one more step, you can rewrite like this. That is A log x minus B divided by x. Okay. So minus, here this can be written as C divided by 2x square plus D. So this is the value of this integration. So while seeing this expression, you maybe feel that is, oh, the given problem is not in the exact form of the formula. So don't worry, you can apply some properties. What are the properties we applied? We applied this a power m divided by a power m equal to a power m minus 1 in each expression, and we separately write the integration. So if you are having plus or minus sign, you can separately write integrals. Okay. So using this, and then we will get that expression in the given formula type. So you can write the final answer. Okay. So now, shall we solve the problem number 4? Okay, dear students, now let's solve the problem number 4, that is integral x plus 1 by x the whole square dx. So students, please be aware that we can again and again, we can apply this integration. What is that? Integral x power n dx equal to x power n plus 1 by n plus 1 provided n is not equal to minus 1. This one thing you should aware, and also you should be careful that this expression is not a single term x. It is the combination of x plus 1 by x. So we cannot directly apply this formula. So we have to again convert this into the form of this expression of this form integral x power n dx. For that, we are going to expand this expression. What is that expression? It is like a plus b the whole square, the famous formula, isn't it? So first we should write that general formula. A plus b the whole square is what? It is a square plus 2ab plus b square. So now this x plus 1 by x the whole square, this can be expanded like first term is x. In the place of a we are having here x. In the place of b we are having 1 by x. So this will give you x square plus 2 into, here a is x, b is 1 by x. So plus b square is here 1 by x the whole square. So what is this? This is nothing but x square plus x and 1x, you can get cancelled. It is in the numerator. See, a number divided by the same number will give you quotient 1. So it will get cancelled. So balance will be 2. So plus this will be 1 by x square. Okay. So now you replace this by this expression. So this will give you integral x square plus 2 plus 1 by x square into dx. Now you are allowed to use this formula directly after this expansion. So as we saw in the previous problem, we can separately write this. So this can be written as integral x square dx plus integral 2 into dx plus integral dx by x square. So this will give you, this will be x square dx. So here n is not equal to -1, you can apply it, the formula, so it will give you x power 2 plus 1 by 2 plus 1 plus here 2. So here you may be asked, there is no expression of x. So in this case, you can write this constant as integral x power 0 dx. Okay, because anything power 0 is 1. So here consider this as 1. So plus integral, this integral can be written as x power -2 dx. So first expression will be x power 3 by 3 plus 2. This will be x power 0 plus 1 by 0 plus 1, because the power is not equal to -1. You can apply the formula. So here x power -2 plus 1 by -2 plus 1. So you integrated all the terms. So in the final answer, you have to write the constant plus c, and you should just mention where c is any arbitrary constant, as we write in the first problem. Okay, so this will be x cube by 3 plus 2, 0 plus 1 is 1, so 2x plus this will be -2 plus 1 is -1, so it will becomes, the plus sign becomes minus, so minus x power -1 plus c. Okay, so you can be integrate any arithmetical expression involving x or 1 by x or x by anything, and you can expand using that formulas, and you can integrate this type of problems using this formulas, integral x power n dx formula. If n is equal to -1, you know that integral x power -1 dx is log x. Okay, now let's solve problems involving this trigonometric expressions or this exponential expression. So now we are going to solve problems involving trigonometric expression, sin x, cos x, secant square x, cosecant square x, and so on. For that, we are going to apply so-called Pythagorean identities. So the famous identity is sin square theta plus cos square theta equal to 1, 1 plus tan square theta equal to secant square theta, 1 plus cot square theta equal to cosecant square theta. So shall we solve these 4 problems? The first problem is integral tan square x. So now let's see the formula board. Here we are having formula for secant square x, cosecant square x, and so on. That means you cannot have basic formula directly for this expression tan square x. So what can we do? That is, you can apply the Pythagorean identity involving tan square theta. So from this second identity, what is tan square x? This will be nothing but secant square x minus 1. Here in place of theta you are having x. Okay students. So tan square x can be written as secant square x minus 1. So this integration is equal to this integration. Now you can write this integral secant square x dx minus integral dx. So now you know the formula for integral secant square dx dx. What is that? It is tan x. So dx, here there is no term, so it will consider as x power 0. If we integrate x power 0, it will give you x. So hereafter you remember that integral dx is nothing but x. So this will be integral of tan square x dx will be tan x minus x plus c. So while seeing the terms first time, you may be worried. So we didn't know that, we didn't have any formula for having solution in the first side as in the previous 4 problems. Okay. So in solving, while solving trigonometric expressions, you should be having some knowledge of Pythagorean identities and some basic standard integration formulas using trigonometric functions. Okay. So if we, by using Pythagorean identity, we get the result in only in 2 steps. isn't it? So, okay, shall we solve problems number 6? So, what is that? So, problem number 6 is integral tan x minus 2 cot x the whole square dx. So, have you any idea? Have you have any idea to solve this integration? Yeah. So, as in the last 4th problem, this is of the type sum a minus b the whole square dx. So, what is that formula? A minus b whole square is nothing but a square minus 2ab plus b square. So, here in the place of a you are having tan x, in the place of b you are having cot x. So, shall we solve this? So, integral tan x minus 2 cot x the whole square x dx. This can be written as integral. So, here a tan. So, tan square x minus 2ab. So, 2 a is tan x, b is 2 cot x. So, third expression plus b square. So, 2 cot x the whole square. So, put the bracket here. So, into dx. Okay. So, this can be written as integral tan square x dx minus 2 2s are 4. So, 4 tan x cot x dx. The final expression is integral 2 cot square x dx. So, this is nothing but now we have to simplify some more terms in this right hand side expression. So, first again you know that you didn't have direct basic formula. So, this tan square x can be written as secant square x minus 1 dx, isn't it, from this expression. And this minus 4 is constant, take it outside. And in trigonometric expression, you all know that tan x and cot x are inverse of each other. That is, cot x is nothing but what? 1 by tan x. So, this can be written as tan x, cot x can be written as 1 by tan x. So, tan x by tan x dx. Plus, you take 2. Again, you see that here, is there any expression involving cot square x? No, isn't it? But you know that cot square having expression in terms of cosecant square x. So, cot square x can be written as cosecant square x minus 1 into dx. So, students, you should be known how to expand this expression, how to apply the basic formulas in the expression given like this. Okay, it is not a much difficult one because you know some basic properties like Pythagorean identities, trigonometry expression formulas, and that a plus b the whole square, like that only we are going to use to solve some kind of problems involving some complexity. Okay. Okay, now this can be written as first term will be secant square x dx minus integral dx. This will be tan x will cancel. So, this is minus 4 integral dx. This term is 2 times integral cosecant square x dx minus 2 integral dx. Okay. So, this first term. So, you have to do some little calculation. So, I am repeating this. So, integral secant square x dx. Now, you see that this is of 3 terms are of the same type. Integral dx, 4dx and 6dx. If you add these, use the integral 7 dx. So, this is 2 times integral cosecant square x dx. Now, tell what will be the integral secant square x dx. It is nothing but tan x. Okay, so this is integral secant square x dx is tan x. This is 7. So as we know, integral dx is nothing but x. Cosecant square x is nothing but give you minus cot x. So we integrated. So final expression, this is 1. So in this you have to write plus c is any arbitrary constant. Okay. So let's recall this. That is, you are applying a minus b the whole square expression. You are writing integration separately, and to apply that formula, we are writing some expression in terms of the known expression. Okay, which are some basic formula. Finally, we are integrating and we got the result. So similar way you can apply to every problem. So now we are going to solve problem of the type integral dx sin square x cos square x. So you may be thought that 1 by sin square x is cosecant x. So it can be written as cosecant square is secant square, but we didn't have direct formula involving both two things. We are only having integral secant square x, integral cosecant square x, isn't it? So we have to think little bit differently. How can we write this? We know the Pythagorean identity, that is sin square x plus cos square x is what? It is 1. So we are going to write in the numerator, we are considering it as having 1 because there is no other expression, isn't it? So we are considering dx separately. Other than dx, there is 1 in the numerator. So here this 1 can be replaced by sin square x plus cos square x divided by, so denominator sin square x into cos square x. So while writing expressions for integration, you should be aware of this binary expressions, that is plus or minus anything. Okay, if you do any mistakes, then whole problem will get wrong answer. So this can be written as, you can separate these two things. So first term will be sin square x divided by sin square x into cos square x dx. So plus the second term will be cos square x divided by sin square x cos square x dx. Now we are familiar with the integration, that's why I am writing two steps in a single step. So I express the two terms separately and then applying the integration. Okay. So now what does this give you? Sin square x will get cancelled, so it will be 1 by cos square x dx. This will be, so dx by sin square x. So it is in the denominator. Now what is 1 by cos x? It is secant square x. So secant square x dx. So what is 1 by sin x? It is cosecant square x. Cosecant x, it is square. So it is cosecant square x dx. Now this integral secant square x dx is nothing but tan x. This is minus cot x plus. See, if you know the formulas and if you know the sum tricks, if you guess that, then in the 4 or 3 steps you will get the answer. Okay. Okay viewers, let's solve the final problem in this class. So here we are having the expression in the integration, it is 1 by 1 minus sin x. That is, this can be viewed as 1 by 1 minus sin x into dx as in the last problem. So now we are going to use some tricks. That's why I am writing only the integrand. Okay, this is 1 by 1 minus sin x. So now how to solve this? So some students will be worried. Oh my God, this is given the denominator, how to solve it like that. So don't worry students. You can easily solve this by using a simple trick. That is, you have to apply the conjugate of this expression. What does it mean? No worry students. You can just write the expression as it is. And if you have minus in the between two things, you have to put here plus. If you have plus, you can write the minus. That is the conjugate of this. Okay. So here 1 minus sin x conjugate is 1 plus sin x. So you have to multiply and divide that expression with this. So this is nothing but 1 into 1 plus sin x divided by 1 minus sin x into 1 plus sin x. That is 1 minus sin square x. So now I think you guessed that 1 minus sin square is what? Cos square x. Why? Because in the two problems we see that sin square x plus cos square x is 1. So 1 minus sin square is cos square x. So this is 1 plus sin x divided by cos square x. So this can be rewrite as 1 by cos square x plus sin x by cos square x. So now 1 by cos square x is nothing but secant square x. We know the formula. Okay. Now this expression, how can we write? This can be considered as sin x by cos x into 1 by cos x. So this is, first expression is secant square x, second expression is sin x by cos x is tan x, 1 by cos x is secant x. Okay. Now, so this integral dx by 1 minus sin x, this will be nothing but integral secant square x plus tan x secant x into dx. So you can separately write this. So plus integral tan x secant x dx. So what is secant square x dx? So this is nothing but tan x, as we saw in the last two problem, and tan x secant x is nothing but secant x, that's all. So if you integrate secant square x, you will get tan x. If you integrate tan x into secant x, you will get secant x. So plus c. So that's all. So if you memorize or well versed in the basic integration formulas, you can solve problems of any type by using some simple tricks. So next, in the next module, we will see some more problems using some tricks. Thank you.